Hi, hello everyone. Myself, I am Rahim. Now let us discuss about the subject is theory of computation. Topic is introduction of the theory of computation. Theory of computation. Introduction of the theory of computation. Abstract. The theory of computation is an essential aspect of computer science and mathematics, primarily focusing on the formalization of the problems that can be computed and how effectively they can be solved. It is divided into three key areas: complexity theory, computability theory, and automata theory. Complexity theory measures the difficulty of solving problems. Computability theory explores which problems can be solved algorithmically, and automata theory explains abstract mission and the computations they perform. Study of computation provides a mathematical foundation for understanding what can and cannot be solved by machine. This foundation helps to distinguish between the solvable problem, those that can be effectively computed, and problems that may be unsolvable or require excessive computational resource. In practical applications, this field supports the development of software and hardware solutions for various computational tasks. Each branch of the theory of computation serves a different purpose. Complexity theory focuses on classifying problems based on the resource required. Computability theory defines what problems are algorithmically solvable, and automata theory formalizes the concept of automation computation through models like infinite automata and Turing machine. Introduction. The theory of introduction of computation is a fundamental concept in the computer science, forming the basis for understanding algorithm and their limitations. At its core, the theory deals with how the problem can be structured, solved, and analyzed using the formal methods. The classical theory introduces the mission that propose inputs string into a output string, where the simplest form of involves binary decision. A central part of this theory is the idea that any computer program can be described as a finite string of characters. That abstraction enables the classification of the algorithms and problems into a different categories based on their computational complexity and solvability. Understanding the boundaries of computation helps scientists and engineers determines what kind of problems are feasible to solve using current technologies. The introduction of the abstract machines such as deterministic finite automata, DFA, and Turing machines allows researchers to model computation in a way that can be applied both theoretically and practically. Automata theory, combinational logic, finite state machine, push down automata, Turing machine. Methodology. The methodology in the study of theory of computational involves formalizing the problems and algorithms using mathematical models. Complexity theory, for instance, use classes like P polynomial time and NP non-deterministic polynomial time to categorize the problems based on how much time or space is required for a solution. This is done by analyzing the worst case scenarios, providing the insight into the inherent difficult of problems. In computability theory, the focus is on identifying which problems can be solved by algorithms and which cannot. This is achieved through the use of models such as Turing machine, which represent the most basic form of computation. A problem is computable if it can be solved by Turing machine, otherwise it can be classified as an non-computable. Automata theory uses abstract machine to represent the formal language, where each type of machine corresponds to a particular class of language. For example, finite automata can represent regular language, while context-free language are represented by the pushdown automata. These models are crucial in understanding how computer recognizes pattern and process language. Result. The result of applying the theory of computation demonstrated that certain problems are fundamentally unsolvable by any algorithm. For example, the halting problem. which asks whether a given program will terminate or run indefinitely is proven to be undesirable. This result highlights the limitations of the computation and the boundaries of the algorithmic solution. In terms of complexity, theory result show that problem in the P class can be solved effectively when problem in the NP class have no known efficient solution but can be verified quickly. The relationship between these classes, especially whether P equals NP, remains one of the most significant open question in the computer science. Automata theory result provide a clear classification of languages and their corresponding computational models. Regular languages can be recognized by finite automata, while more complex language, such as context-free language, require diffusion automata. These result help in designing algorithms for tasks such as parsing, programming language, and developing compilers. Discussion: the implication of the theory of computation extends beyond theoretical computer science, influencing areas such as software development, cryptography, and artificial intelligence. Understanding the computational limits allow researcher to focus on feasible problem and create efficient algorithm for real-world application. One of the ongoing challenges in determining whether there are efficient algorithms for NP complete problems. These problems are critical in fields like optimization and cryptography, and a breakthrough in this area could revolutionize computing. However, the inability to solve the NP compute problem in polynomial time with current knowledge creates a significant barrier. In automata theory, the practical applications of abstract machine includes pattern recognition, lexical analysis, and the design of the communication protocols. So these models are fundamentals for understanding how system process information, making them essential for tasks ranging from compiler construction to network design. Conclusion: the theory of computation provides a deep understanding of what can be computed and how efficiently computation can be performed by categorizing the problem into the complexity classes. Determining the computability can be performed by categorizing problem into the complexity classes. Determining the complexity sheet and modeling computationals with the automata, researchers gain insights into the capabilities and limits of algorithm and mission. The study of complexity theory, computability, and automata theory equips computer scientists with the tools to satisfy problems, optimize algorithms, and design efficient systems. These theory form the backbone of the much of the modern computer science and are applied in the wide range of the field from software developments to data analysis. Future research in the theory of computational will likely focus on unresolved problems such as P versus NP, as well as expanding the understanding of the quantum computing and its implication for classical computational models. The ongoing advancement in this field will continue to shape the future of the technology and computation. Thank you.